One of the things that we face in mathematics is the plethora of word and story problems of all different types that we have. So here I want to focus specifically on what are called number problems. Number problems are problems where you're given a sentence or two and you have to translate those sentences into equations to be able to solve for missing variables. So one of the biggest things that happens with these problems is you have to know how they break down and what it is that you're doing. So you have to be able to pick apart and pick out the important information. Okay. So I was just going to go through a couple different examples of different sentences, show you how to pick them apart and write the equations that are being discussed, and then how to finish out solving those problems. So the first one says one number is 10 more than another. So in picking this apart, we have a couple key information. First is this first part. It's talking about a particular number. This would be a variable. So I would call this one, say, x. Whenever we talk about the word is, well, this means equals. Okay, is the same thing as equals. There's a bunch of other words that mean it as well. And then we have 10 more than another. Okay, so first of all, another is talking about something different. So another here to me would be something like y. When we are looking specifically at the more than piece, we are talking about add. And then this than part, okay, so this part here is a turnaround phrase. So what that means, because of more than, it means this part comes first and then the 10 comes second. So when we look at this whole entire first sentence, what we actually have is we have the equation x is 10 more than another. So y plus 10. Now, if we look at the second part of the sentence here, we are now creating a new equation. So when you hit a period, that's a sign that whatever equation you were writing has now come to an end. And so this would be a whole brand new. And so first it says if their product is 25. So here there is referencing the x and the y. And then again we have product right here. So this would be your multiply. Again, you have the word is, which is your equals. We have, or at least you can see, that we have a second equation. And that second equation says that x times y is equal to negative 25. The whole question asks you to find the numbers. So what we have is we have two equations here that are going to play off of each other. This equation is going to be substituted in for this x value because I'm telling you what x equals here. So in this case, I can rewrite my equation to say y plus 10 times y is equal to negative 25. Now, in order to actually find the numbers, I would need to distribute this y in. So this is going to give you y squared plus 10y equals negative 25. I gotta take this negative 25 here and move it to the other side of my equation. So here we get that y squared plus 10y plus 25 is equal to 0. In looking at this, you can see that you have a perfect square trinomial. We get that by looking at the first term and looking at the last term. And this is perfect squares, which means if you take the square root of the first term, you're going to end up with just y. If you take the square root of this back term, you get a 5. So what this means is that you have y plus 5 squared equals 0. When we're talking about y plus 5 squared, what we have to remember is that's the same thing as having y plus 5 times y plus 5 equal to 0. We only need to worry about it once because twice is overkill. So we're going to set y plus 5 equal to 0, which means y equals negative 5. Once you find the first term, now we can go back and find the second. So we can take this solution and we can plug it in here for y. So we know that x is equal to y plus 10. Since y is negative 5, that means negative 5 plus 10, which means x is 5. So your solutions here are that x equals 5 and y equals negative 5. Now you can take both of these and you can plug them back in to your answers and double check, and you should see that they both work. Okay, so that's the first one. Let's go ahead and work a couple more. So we have, if the square of a positive integer, so positive is the first big thing, is added to 3 times the integer. So I'm having a positive integer, and not just that, I'm looking at the square of it. So I would consider this to be along the lines of x squared. And then is added to, so added is going to be just that, your plus sign. And then you have 3 times the integer. So the integer, this is referring back to this integer here. So this would be like saying 3x. The result is, so this thing here is your equal sign, is 54. Find the integer. So what do we actually have here? Well, we have that x squared plus a 3x is 54. So now we just simply have to solve the equation. To do that, we need to move the 54. So this becomes x squared plus my 3x minus 54 equals 0. In this case, if we were to backtrack it into its factors, x would break down into x and x. This back number here tells us which option we have to use. It's one positive, one negative. And then I need to have factors of 54. So here, if we look at 54, we can look at all the factors that 54 has. So first and foremost, we have 1 and 54. We have 2 and 27. 3 and 18. 6 and 9. Now, the other thing that we have is we have this sign up in front. What this sign tells us is this sign tells us that the bigger factor is positive. So what that means is that all of these factors down here on this column, all the bigger column, these are all positive, which means my little factors are all negative. So I need a combination of these factors that when added together give me 3. So that combination here would be this bottom one. So that would tell me that I have positive 9 and negative 6. So I need to set both of them equal to 0. So that gives me x plus 9 equals 0 and x minus 6 equals 0. So x equals negative 9 and x equals 6. Now here I have two solutions. However, again, if you remember, the very first thing I said is that positive is the key in this problem. What that means is that we can cross off the negative, and the solution to our problem is the positive 6. Alright, let's go ahead and do another one here. So I have one number is 5 less than another. So again, I've got this one number, so I would consider that to be, say, the x. You've got your is part, which is your equals, and then we have less than here, which is that turnaround. So it says that this back value has to come first, and we're talking again about another, so I would call this y. Less than means we're going to subtract. So our first equation would simply be that x equals y minus 5. And then this back part says the sum, so here we are talking about addition, of their squares, so the their part right here is referencing to the variables of the previous problem. So this means x and y. We're talking about squares, so this is your power of 2. Here's your equal sign, and it is 97. So in this case, we have that the sum of their squares, so x squared plus y squared is equal to 97. So here we need to find the numbers. So again, I'm going to take this x and we are going to plug it into this equation down here. And so when we do that, what we end up with is we end up with y minus 5 squared plus y squared equals 97. Because I have y minus 5 squared, remember that's the same thing as having y minus 5 times y minus 5 plus a y squared equals 97. In order to do this, you need to FOIL. So first, outer, inner, last, and we're going to multiply all that through. So this is going to become y squared minus 10y plus 25 plus y squared equals 97. Combine my two y squareds together and then take this 97 and move it. So here we have 2y squared minus a 10y, and then we have 25 minus 97, which is negative 72, is equal to 0. So at this point, we now can solve. So here again, I have 2y squared minus my 10y minus 72 equals 0. So let's go ahead and solve this. The first thing that we can do is we can pull out the greatest common factor, which is 2. So we can pull that 2 out, and it's going to leave me with y squared minus 5y minus 36 is equal to 0. I can divide this 2 out, so I'm just looking at the y squared minus 5y minus 36 equals 0. And then again, I can factor. So once again, this one here tells me that I am going to use positive times negative. And then this front one here tells me that the bigger factor is negative. The last thing I have to look at is I need to look at what my factors of 36 are. So I have 1 and 36. 2 and 18, 3 and 12, 4 and 9, 6 and 6. Now with that, I have to look at the information I have. So one of the things again is that the bigger factor has to be negative. So that means this column of larger values is all negative, and it also means then my other column is all positive. And I need to know which combination of these will give me a 5, specifically negative 5. So the one we're going to look at here is going to be this middle one. So that means I can break my equation down into its factors. So this becomes a y and a y. Again, I have plus and minus, and then if we look, 4 was positive, 9 is negative, so 4 and 9. And then in this case, we can set each equal to 0. So y plus 4 equals 0, and y minus 9 equals 0. Solve them each. Y equals negative 4, y equals 9. And so here we have two potential answers that we're working with, which should make complete sense considering the fact that we're dealing with square numbers. So now we have to go back to the fact that we also had another equation in the beginning, which is that x equals y minus 5. So here, if my y was negative 4, then x equals negative 4 minus 5. So x would equal negative 9. However, if y was 9, then we would have x is 9 minus 5. So x was 4. So when we're talking about our solutions, we are talking about two potential possibilities. So right now, we have the possibility that x is negative 9, y is negative 4, or x is 4, y is 9. Now with that, you could check your work. To check your work, which is something I would recommend, which is going to be one way to root out if you have a solution that is a false solution, is to go back to your other equation, which in this case we had the sum of their squares, so x squared plus y squared was equal to 97. And take each set and plug each set in. So this is what we're going to check. So the first thing we're going to look at is I have negative 9 squared plus negative 4 squared should give me 97. Negative 9 squared is going to give you 81. 4 squared is going to give you 16. Does this equal 97? Well, in this case it does. 97 equals 97. Then you can go with the other route. So we can start with 4 squared plus 9 squared should equal 97. 4 squared is 16 plus 9 squared is 81 equals 97. Therefore again 97 equals 97. So that's just what you can do if you want to check your work. Otherwise, your solutions would be both sets here. Okay. So let's look at this last one here. It says, one positive number is 3 more than twice another. So when we're looking specifically at this first sentence, it says one positive. So again, that is a key part. So a positive number, in other words, x, we have the word is, which is your equals, so equals. The more than piece means we're doing addition, and it also means that the stuff that comes last has to go first, and because we have another number, that means a different variable. So twice another, so 2y more than plus, and then we've got our 3. Now the second equation says if the square of the smaller is added to the larger, the sum is 51. So we have to figure out which is smaller. To do that, it comes from the wording of the first sentence. One number is 3 more than twice another. This would tell us that in this problem, x is larger, y is smaller. Therefore, if the square of the smaller is added to the larger, so x plus y squared, then the sum is 51. So here in this case, again, we can take our value for x here and plug it into this equation and be able to solve. So here this is going to give us 2y plus 3 plus y squared equals 51. We have to move that 51 over, so rearranging your equation, we have y squared plus a 2y minus 48 is equal to 0. So here again we can put these into their factors. So this is going to split into y and y. Again, my back sign back here tells us that I have one positive, one negative. The positive sign here tells me that your bigger factor is positive. And here I need to have factors of 48 that are going to give me a 2. So 8 and 6. I can then again solve each. So y plus 8 equals 0. Y minus 6 equals 0. So y equals negative 8. Y equals 6. And in this case we have a decision to make, and this goes back to again the fact that we're talking about positive. And so here we would get rid of my negative and we would use the positive y. We would then take that positive and we would come back up here to solve for x. So in doing so, my x is going to become 2 times 6 plus 3. 2 times 6 is 12 plus 3 gives you 15. So your solutions are going to be that x equals 15 and y equals 6. So those are 4 different examples that have to do purely with solving number problems. If you have any questions or concerns, please let me know. Otherwise, I hope you enjoyed, and I'll see you next time.